So I came across this article called The Falsehoods That CS Students Still Believe Upon Graduating, and as someone who's graduating in about a year or so, I thought it would be a good idea to actually give my take on this. So if you're new to this channel, remember to subscribe and ding the little bell icon down below because it'll really help the channel out. I'm trying to hit 100 subs by the end of the month at this stage, and we're getting very, very close to doing it, so any help would be really appreciated. So now that's out of the way, let's get started. Good afternoon everyone, and welcome back to the channel. So, I found this article on Hacker News, but it's on a website called Netmeister, and basically it's titled Falsehoods CS Students Still Believe Upon Graduating. There's 100 points in this article, so I might not show all of them, we'll see how we go. So first thing we have is, they know C and C++. If you think that you know C or C++ after doing it for, I don't know, maybe a semester, or maybe you've done more, maybe it was the core language you used for your degree. You really don't know the language. Until you've actually applied that to some real projects, you really don't know it. Java is a reasonable choice for all programming tasks. It's a fine language. There's obviously going to be a lot of stuff where it's not the best language to pick, like embedded systems or web development, obviously. But for a lot of stuff, it's generally fine. So, programming equals computer science. This is something I see a lot of people actually making a mistake on. So programming is the act of actually coding, whereas computer science is more like the research of how computers function, things like computer language theory and how Turing machines work, things like that are more like what would be considered computer science. People with CS degrees are good programmers. I know plenty of people with computer science degrees who are not good programmers, so I can definitely attest to that. People with a CS degree know how to program. That I can also attest to being absolutely the case. There are a lot of people who just don't know how to program, who are some of my lecturers or some of my tutors who, yeah, they just don't know how to program because there are other fields in computer science you can go into that don't involve programming. CS professors know how to program. Yeah, even the ones who are running programming courses, a lot of them don't even know how to program. CS professors know how to use a computer/mobile device or how the internet works. Sadly, this is actually the case. So, I have a lecturer for one of my maths classes, I think it's computer science for software engineers, and he barely knows how recording his screen works. One of the times when he recorded the lecture, he didn't even realize he had the mic turned off. You should always add lots of comments to your code. So comments are one of those things that are important, but with more experience, you realize that adding as much as you do early on is a massive waste. So early on in a lot of projects, lecturers will get you to add way too many comments. Commenting things that don't need commenting like variables and things like that are self-explained by the name. And when it's self-explanatory by the code, there's no point doing that. So here's the one that basically made me want to make this video. So sprinkling printf statements is an efficient debugging technique. This person is one of the people who is a devout debugger user. The way that I see it is, early on, you sprinkle print statements through everything because you don't know any better. Then you learn about debuggers. And then you realize that debuggers are a massive waste of effort, and you go back to print statements because you can generally get everything you need done with print statements. A lot of people are going to disagree with me on that point, but I don't really care. I keep saying I'm going to make a video about that at some point, but I keep forgetting to do it. Compiler warnings can be ignored as they'd be errors otherwise. It depends on what the warning is. If it's a warning like it's an unused variable and you're doing general development work, it's probably fine. If it's on an embedded system, however, maybe that's an issue. But generally, compiler warnings aren't that much of a problem. There's some cases where they are, however. If it builds on your laptop, it will build on everybody else's. This is definitely not the case, especially when you're working with things that are more hardware level, or even just things like dependency management with languages that don't have good dependency management, like Python, for example. There's a lot of times where just getting those dependencies set up is going to be a massive pain, but then if you, say, have a bit of code that you wrote for Windows, then you try to compile it on Linux or macOS, it might just not compile at all. So yeah, I absolutely agree with that. If the code is on the internet, that means you can use it. So this gets into the weeds of licensing and how each of the different licenses work, like how MIT works, how GPL works, how Apache works. And a lot of the time, you can use the code, but if you're going to be reusing someone else's application, there's a lot of times where you do have to actually go and understand what that license means. Generally, it's probably okay to use code you find on like Stack Overflow or somewhere like that. But when it comes to actually reusing application code, then you're going to maybe run into some difficulties. So free software is free. I could probably do a half-hour video on what free actually means. What I believe it's referring to here is that if you have free software, that means it's probably going to be scraping your data, and in that case, you're paying with your data, so it's not really free, but it's monetarily free, so in that case, it's free. Or it might be free as in the cost, but it's not free as in the use. There's a bunch of different meanings that free has within the software industry. Open source means it has fewer bugs and is more secure. Depends. Once again, most of this is a depends. Being open source means that people can audit it easier, and when something is closed source, that doesn't necessarily mean it's safer just because people can't see the code. But there are cases where it is safer, but with closed source code, even though you can't see the actual source code, you can still treat it like a black box, hit it with input, and then see what the results are, and you can still break it like that. So in that case, open source is more secure and closed source is less, but there's other ways that it's more, and it's a very complicated topic. Git and GitHub are synonymous. I actually made this mistake myself for a while. I didn't realize that GitHub was a separate thing. I would always say I was using GitHub for source control, but obviously those are completely different things. You should know that. That's a very important thing to know. Unix and Linux are synonymous. Unix is the big branch root of the entire BSD, macOS, Linuxy, Android world, and Linux is just one of those branches. Email and Gmail are synonymous. At one point, Gmail was email. Now it's kind of this email thing with a bunch of stuff bolted onto it, and it's not really email, but it kind of is, and it breaks a lot of email clients because of that. Bash and SHA are synonymous. This one I see that a lot of people who are actually like regular Linux users actually making. Bash is not SHA. So SHA basically refers to the standard shell that you've got on your system. That could be Bash, that could be Z shell, that could be the C shell, could be anything. And Bash is just one of those shells that you could have. AWS and cloud services are synonymous. I don't know who's making this mistake. AWS has been around. It's been around for most of the time that we've had like the general idea of what we think of as cloud services, but there's other things like Azure and whatever Google's platform is and all the other ones. Privacy and confidentiality are synonymous. Confidentiality is kind of encompassed by privacy, and privacy is part of confidentiality. They have different meanings, but confidentiality basically refers to keeping data secret, whereas privacy refers to that as well as a bunch of other different things. Once again, with this other one here, encryption and security are synonymous. Encryption is a part of security, but security also includes other things like making your code so it's not easy to crack and other things like that. Making it so you can't just do SQL injection and a bunch of other things that security basically encompasses, but encryption is only just one part of that. Smart people write clever code. I don't want to say that I'm smart, but I know that I write terrible code sometimes, and I know that there are people who are significantly smarter than me who will just write hacks to get stuff done. Productive coders write lots of code. Productive coders are going to find ways to write less and less code. If you can move that into a module and you can just repeat that module everywhere, that's much easier than having to manually write that everywhere. So being able to program is the most important aspect of being a software engineer. I would say that it is the most important part, at least from the time that I did my job, but there are other things that are almost as important, like communication skills are also very important. Being able to explain what you're doing to a business person who has no idea about programming is a very important skill to have. But if you can't program, you're going to have to pretend like you actually do know how to program to keep your job. Having a CS degree is necessary and a sufficient condition for being a good software engineer. As we mentioned earlier, you can be a terrible software engineer and have a CS degree. And at this point, I kind of wish that I had done a code bootcamp because that would be much quicker and I would be working by now. Real programmers use neon green on black terminals. No, real programmers use white on black terminals. Obviously, it doesn't matter what your theme is, but whatever you want to use. Command line tools should print colorized output. They should print colorized output as an option because it is easier to read, but they should have a plain text version just so it doesn't start breaking pipes. TED Talks are science and the information presented is accurate. Some of them are. A lot of them aren't. A lot of them are really bad. Software with version numbers ending in 0.0 are buggy and should wait until the next release. Any release could be buggy. Anyone who thinks that has no idea what they're talking about with software. Parsing timestamps and dates is simple. No, because time is broken, just like every other part of the world. Like names, here we go. They know how to validate an email address. No one knows how to validate an email address because they are broken. Did you know that you can have an infinite number of @ in an email address? I bet you didn't. Did you know that you could put quotation marks in an email address? I bet you didn't know that either. Because emails are broken. They know how to validate a host name. You can validate the structure. Validating the actual host name is probably much harder. They know how to validate an IP address. Once again, you can validate the structure, but validating it as a actual IP address that's allowed is way harder. They know how to parse HTML. HTML is a really bad markup language, and it's really great at the same time because you can have half-completed tags, and that's fine sometimes. As you should see from, just write some broken HTML in your browser, see what it does. It's going to work surprisingly well. They are good at multitasking, as is evident with their ability to take notes in class and check Facebook at the same time. No, pretty much no one's good at multitasking. Multitasking is one of those things that a lot of people say they're good at, but in reality, they're just putting less effort into both of the things and don't really get much done. They understand teamwork based on their senior design project. You probably don't. You probably work with a very small team who you probably or someone else took complete charge and then maybe had someone who did nothing until the last second. Actually, maybe this is kind of like working in a team. I don't know. But you don't really understand what it's like working in a team until there is that monetary backing and the massive time constraints that come with that, and you have all these stakeholders who are coming at you. It's much more stressful than just working by yourself with a deadline for your professor. Employers care which courses they took. They care in the context of you understanding the content of the job, but if you're like, I took CS 402, they don't care. No one cares. They care about what you know and what you're going to learn. Sure, they could go and get a PhD. Don't want a PhD, it's stupid. But first they'll make some money and then they can always come back later. Well, you can always go back later, but you don't want to because you're making real money. You're not going to be going back to minimum wage doing your PhD. Well, it's a bit above minimum wage, but still. You don't want to do a PhD after you're starting to make real money. The network is always reliable. The network is never reliable. Third-party services are reliable. They are never reliable. AWS is reliable. Google AWS outages. And you'll see what I mean. One of the first results is top 7 major AWS outages. No, it's not reliable. It's more reliable than some things, but it's not reliable. Okay, but it is when you have redundancies in multiple geographic regions. What if the connections between the regions fail and you've just broken everything? Funny names are funny. You can always change them later. It depends on if you have time. I sometimes forget about them. I think I left a comment about me having some hack code in my last project. Variable names should be as short as possible. Vowels cost extra. No. They shouldn't be as long as some people think they are. Like, I've got a professor for my iOS course who intentionally just gives the most ridiculous names for his variables in Swift. They're usually like 50 characters long because he doesn't care. Don't do that, but don't also just cut letters out for the hell of it. I/O efficiency increases linearly with the size of the buffer you use to read data into. It increases to a point, but there's always going to be an issue with that. You can read the entire file into memory. It depends on the file. If you're trying to read an entire, terabyte database into memory, no. But if you're like, I want to read this vimrc into memory, yeah, you can do that. It depends on the context. You can always write to the current working directory. There's actually a lot of times when you can't do that. One example is if you delete the working directory. So there's one example. But you might have a situation where the program is running in a directory where it needs root access, for example, but it's running in a sort of container thingy, so it doesn't actually have access to the folder it's in. You can always write to temp. There might not be a temp directory, for example, or there might be some other restriction on that for why you can't write in there. The error message, no space left on the device, means you're out of disk space. it can, but it can also mean that that memory, for example, on Windows, you can have I forgot what it's called, page memory, something like that, where that will take up a bit of your memory, but it doesn't actually tell you what's taking that up. So at one point on Windows, it would say memory left and then actual memory left or something like that, or storage left. And the actual storage left would be higher than the current storage left because there was that page file there. Okay, so this is actually going way longer than I was expecting to. I think we're at like 17 or something minutes. So I think we'll stop it there, and I'll come back and do a part 2, I reckon. So if you like this video, and you like this different sort of style where I'm trying to actually just go over a random little article that I think is a bit of fun, remember to smash that like button and leave me a comment down below letting me know what you think. And if you want to see more videos like this, remember to subscribe and ding the little bell icon down below because it'll really help the channel out. And up on that corner, there will be a playlist that this video's in. I'm not sure which playlist at this point. Maybe tech news. No, tech news probably doesn't work. Maybe off topic or something. I don't know. So check that playlist out and you'll see something else that you might enjoy. And I think that is pretty much everything for me, so I'm out.